Hello, I'm Craig, and welcome to my Unity 3D tutorial series, How to Write Q Bert from Scratch. This is part 4 in the series, and in this video we add the transport discs that will transport Q Bert to the top of the pyramid and help him evade Coily the Snake. Speaking of Coily the Snake, we finally get him into the game and animate it and chasing Q Bert around the pyramid. So grab your favorite beverage, pull up a chair, and follow along as I teach you how to write Q Bert from scratch in Unity. In our previous video, we added scoring in UI, so now you score points as you flip platforms to different colors, and you can see the score updated up here in the UI. We display what level we're on, our high score, and we have an indicator here for how many lives we have remaining. And there you can see that gets decremented when we spawn a new Q Bert. So the next thing we want to add are transport discs, the little discs that are down at the bottom edge of the pyramid that Q Bert can jump onto that will transport him back to the top of the pyramid. And if Coily the Snake is in close pursuit while he does that, the snake will jump off the edge to its death and any other enemies on the pyramid will be removed. So to create a transport disc, let's start with an empty game object. We will right click, create empty, and call it transport disc. And then we will add to that a cylinder. So right click, 3D object, cylinder, and we'll just let that stay cylinder. We're going to scale it up on the X and Z axis and scale it down on the Y axis, giving us a nice disc shape. I think that looks pretty cool. Now let's create a material for that. We'll go into our sprites folder, and you'll recall we imported some images in an earlier episode. I drew this image, and you can see it's not the prettiest image. It's got some rough lines, but it will do fine for what we want to do here. I do want to change it from 248 to 256, from 2048 to 256 for the max size, and click apply. And we are going to create a new material from that. So let's go to materials, right click, create material. And then for our base map, we will take that image and drag that right in there. And that gives us that nice material there. So we can drag this material right onto the disk. Look at it from the top. Look at it from the side. You can see that looks really nice. All right. We can go ahead and create a prefab from that. We'll go to our prefabs folder. We'll drag that transport disk down into there. And I'll go ahead and delete this from the scene. Now we're going to want to write a script for the transport disk. So let's go into our scripts folder, right click, create, C# script, call it transport disk. Double click that to open it up in the editor. Zoom in and delete all this boilerplate. I'm going to add a using DG tweening because we're going to use do tween in this class. And let's create our serialized fields. We're going to have a float that will be our rotate speed. And let's just set that to 500. We may adjust that in the editor depending on how it looks. Let's create a vector 3. Actually, I want a couple of vector 3s here. These will be our destinations, depending on whether we're on the left side or the right side of the pyramid. And we'll need some private variables. We're going to have a destination. We're going to have a couple of transforms. We're going to have our transform and our child's disk transform. That's so we can rotate the disk. We only want to rotate the disk, not the parent object. And we need a bool. I'm going to make this a property that with a public getter. This is going to say whether or not the disk is active. So we'll say public get private set. We can only change it in here. And I'm going to move that down below. And then let's add another property here, or a variable here for our Q Bert. We're going to get this off the collider when Q Bert jumps on us, and we're going to use this to communicate with the Q Bert object. So we need to tell Q Bert when to jump to the platform when we've reached our destination. So let's do some stuff in Awake. We want to initialize some things. We want to grab our transform. And we want to grab our child disks transform. And we get this with the transform get child method. And we only have one child, which is our cylinder. And so we can save that off to our disk variable. Let's do some stuff in update. We first of all want to check to see if we're active. If we're not active, we're just going to return and not do anything. Otherwise, we want to rotate our disk. So we'll say disk.rotate. We're going to rotate only on the y-axis, so nothing on the x-axis. The rotate on the y will be our rotate speed times time.delta time. Nothing on the z-axis. And we want to rotate on space.self. All right, we want to check to see if we reached our destination. So we're going to have to add a property for that. If we haven't reached our destination, we're just going to return. We're going to have to tell, so if we have reached our destination, we're going to tell Q Bert to jump to platform. We're going to set isActive to false. And we're going to deactivate ourselves. Let's add our property reached destination. And we're just going to use mathf approximately. We're going to see if the distance from our transform position to our destination is approximately 0. Okay. Next, we want to handle on collision enter for when Q Bert jumps onto the platform. So I will say void on collision enter. On collision enter. I'm going to rename this to other. And the very first thing we want to do is check and see if we can get a Q Bert game component off of the collider's game object. So say if not collision.collider, actually it's going to be other.collider.gameObject.try get component out Q Bert return. So if we're not able to get a Q Bert game object from whatever we collide it with, we're not going to do anything. So I guess it's possible, but not likely that Q Bert the Snake might jump onto us. We don't want to handle that. We only want to handle Q Bert jumping onto us. We want to parent Q Bert to our disk. So we'll say Q Bert transform set parent transform. We want to call a new function called activate disk, which we will create down below. And we want to call a method on Q Bert, land it on disk, which doesn't exist yet. Okay, so activate disk. What do we want to do here? We want to get our destination based on whether we're on the left or the right side. So we're just going to look at our transform position. If it's greater than, actually the z-axis, if it's greater than 10, which is roughly the middle of the pyramid. So if our position is to the right of the middle of the pyramid, we know we're on the right side. So we'll use destination right. Otherwise, we'll use destination left. So this is a ternary operator. It's just shorthand syntax for basically if this, then that, else that. We've used that before, but I just wanted to just run through that real quick. We're going to set our isActive flag to be false, or to be true. We're now active. We want to tell the score manager we used a disk so that it won't give us bonus points for that disk. So we'll say score manager.instance.use transport disk. We already implemented that when we were writing the logic to calculate the bonus points. And we want to tween to our destination. So we will say transform do move, which is a tween extension method. We're going to move to our destination over a period of 2 seconds. We are going to use a linear easing, and we want to set auto kill to be true. All right. I think we should go ahead and implement these functions on Q Bert, but first I want to assign this script to the TransportDisc prefab. So if we go up to our prefab transport disk, go into our scripts folder, drag that TransportDisc script onto there. And I think these are fine for destination left, but I think destination right should be 2.5. I think 0.32 and 2. We'll play around with those probably. We're going to want to have the BoardManager spawn our transport disk. So we're going to want to make some changes here in the BoardManager class. So we've already got these comments here. So let's add our serialized field for our transport disk prefab. And we want the vector 3s, which will be our spawn positions for those disks. So that will be an array of vector 3s, transport disk positions. Okay, and we're going to have a list of transport disks. And I think that looks good in terms of variables. We want to instantiate that array down here in awake. Okay. So let's set up our transport disks. First thing we want to do here is we want to say if transportdisks.count is greater than 0, then we just want to reset the transport disks because we've already created them and we're going to reuse them just like we did with our pyramid blocks. Otherwise, we want to create them. Let's make this plural. All right, so just go and do those down at the bottom of the file. We're going to loop through our disk positions. We're going to instantiate a disk at this disk position using quaternion identity. And let's try and get a transport disk component off of it. And that should always work because we know the transport disk prefab has the transport disk script on it. And we're going to add that to our collection of transport disks. And then we are going to tell that disk to be parented to us. So basically the GameManager, the BoardManager, owns all the parts of the game board. All of the platforms and the disks will actually live underneath of the BoardManager component in the hierarchy. And let's go down to our reset transport disks function. This time we will use an integer and iterate through these arrays. So I is less than transport dispositions dot length increment I. And so if you're not familiar with the for loops, This is your initialization. This is your condition to see if we should break out of the loop. And this is your reinitialization. So when you first come in, we initialize I to 0. We check to see if I is less than length. And as long as it is, we will execute the body of the loop. After each iteration of the loop, we will execute this. So we'll increment I and then compare again and so forth. So transport disks at the I position will be transport disposition sub I. So transport disks at 0 will be equal to the transport disposition 0, and then 1 will be equal to the position at 1. And we want to activate it. We're setting the game active to be active, the game object to be active. We're not actually, if you remember, there was a property on the transport disk is active. That's not the same thing as what we're doing here. This is just turning on the disk so it's visible on the board and Q Bert can jump onto it. Okay, if we go out to the Unity editor, I think we've got our prefab set up. We go and look at our transport disk. We've got our disk positions. We've got our destinations. The board manager. The board manager needs to be set up. So go into resources, managers, game manager. And the game manager has a board manager. That's where we need to add these. So the transport disk prefab needs to go in there. And then we need to set the positions for where we want to spawn those guys. So I think the one on the left will go -4, 6, 3. And then the one on the right will be 15, 6, 22. Okay, let me just hit play and see if we spawn our transport disks. Well, we spawned them, but this one's in the wrong place. That one looks okay, but that one clearly is not right. So let me double click the game manager. Those values should be right, I believe. That's really interesting. Let me hit play again. Hit pause. We will go and look at the hierarchy. So under Don't Destroy and Load, Managers, Game Manager, we got that transport disk. That's the left one. And that is at -4, 6, 3. Then we click this one. This should be 22. Yeah, so that puts it in the right place. So let me go back out and go into Resources, Managers, Game Manager. That is very confusing to me because I am setting it here. So I wonder if this is just some weird Unity bug. I'm going to delete this, type it back, and exit this field. And hit play again. And there it is. That was bizarre, to say the least. Now, in order to have Q Bert jump on the disk, we need to add something to the board manager so we can know if there's a disk at the position that Q Bert's jumping to. So if we go back into our scripts, managers, board manager, we're going to add a function. So we got this landing out of bounds function. I think we want to add another function that will tell us if there's a transport disk at a particular position. So let me say public transport disk at position. And it will take a vector 3. And I'm going to use link. And I'm basically going to search through our collection of transport discs and see if there's any that are, I'm going to say, within 3 of the position that was specified. I just want to make sure that I have some cushion because of the way I'm calculating my destination. The disk is not at the exact same interval as a platform would be. So I need to have some cushion to see if there's a disk that he can jump to. So I'm going to say transport discs first or default. So this is a link query that I'm doing. And I'm going to use a lambda expression here. I'm going to say disk. So basically, for every disk in this collection, it's going to check to see if the distance from the position that we passed in to the disk's transform position is less than 3. So it's going to find the first one in that collection, excuse me, if it's less than 3 units. Okay, so that will return that. And this will be null if there was no disk within 3 units of that position. So now we want to add some logic to Q Bert. So let's go into Q Bert. And let's see. So we have this here where we're already checking to see if we jumped to a disk. Basically, we're just going to return if we jumped to a disk. So what we really need to do here is implement that jumped to disk function. So I want to put that down around that perform jump. Right around here would probably be a good place. Okay, jumped to disk. We need to get the destination that we're jumping to. Let's see, vector 3. We'll start with our landing position. And we want to subtract 3 on the y direction. And we're going to call that function that we just wrote TransportDisc at position, disk position. So if that's not, if we didn't get one, if there's no disk there, we just want to return false. Say, no, we did not jump to a disk. Okay. Otherwise, we want to call perform jump to the disk's position and return true. I think that should handle jumping to a disk because we already, in the disks on collision enter, handle Q Bert jumping on them. Oh, there's a function that Q Bert is going to call, we need to add, called landed on disk. So let's do that. We'll add that down here. Landed on disk. And we're going to have a bool to know which one we landed on because we want to change Q Bert's facing based on which disk we landed on. So we're going to trigger our landing animation. And then we want to change our facing. And you see they're going to be northeast or northwest. So let's go back into the TransportDisc script. And how do we know? I think we just want to say if our position is less than 0, our X position. I think that will work. We also need a function on Q Bert to tell Q Bert to jump to the platform. So Q Bert jump to platform. Let me save this first. Okay, now I'll create that. So jump to platform. What are we going to do in there? We want to set our parent to null because if you remember, we parented ourselves to the disk while we were riding on it. We want to change our facing after we jump. And depending on which, let's see. We're either going to be south, east, or southwest. So if we're on a platform that's to the left, we want to face southeast and jump down. If we're on the other side, we want to face southwest and jump down. And we're going to just tell them perform jump to the start position because we're jumping to the top of the pyramid. All right, let's go back into the Unity editor and give this all a test. Well, that did not work. And I don't see any errors in the console, so let's see if we can't figure out what happened. No, you know what? I don't even need to debug. I know exactly what's wrong. We never added a collider to our transport disk. So go to our TransportDisc prefab. We will add a box collider. And we definitely can scale that down quite a bit. Let's edit the collider here. We're looking at it from, looks like we're looking at it from the X. So we want the collider to be at the top. We don't really care about the bottom, but we want it to be at the top of the disk. And we want it to extend out enough that Q Bert can land on it. Let's look at it from the top. It's not going to be perfect since it's not round. But that should be good enough that Q Bert can land on it. All right, let's go ahead and give that a shot. Well, not quite. For one thing, it looks like my destination is wrong. The other thing, it was spinning way too slow. So let me go ahead and change that to like 1,000. You know what? These values are completely, I don't know where I got these values from. I don't know what I was looking at when I did that. So that should be 0. This should be 18. This should be 22. This should be -4. This should also be 18. So both of them are going all the way up to the top. And this should be 18. So the only difference is the X and the Z, depending on whether we're on the left or the right. Let's give that a shot. Q Bert is positioned up above there for some reason. I don't know if that's a problem with my collider. But that definitely seems not right. So let me hit play again. And then after I jump onto the disk, I'm going to pause and just take a look at this. Actually, in order to do that, let's see. So let's take a look at Q Bert. Oh, he's parented to the transport disk. So his collider looks fine. The transport disk's collider looks fine. Oh, you know what? The cylinder still has its capsule collider. We want to remove that. Okay, bit by bit, little bit by little bit. Let's go down, cylinder. Let's remove that capsule collider component. Hit play. There we go. Beautiful. All right, got that working. Next, we want to begin adding Coily the Snake. For Coily, we're going to use an asset that I found on itch.io. It's an FBX file that somebody put together in Blender, and it has a lot of different animals in it. So I'll actually, in my editor, show you our assets using this project file, and you can see here under models there's this everything library 01-animals. We're using the snake model from this, and I found this on itch.io, but this is the actual web page where you can go grab that zip file. I've already unzipped it and I have it here. So what we're going to do is we're going to go back into our Unity editor, and we're going to drag this FBX file into our Coily folder. Now, like I said, there are a ton of animal models and stuff in here. The one that we want, these are not named very well, unfortunately. I mean, you can see there's just a gazillion of these, and they're all called base. We just need to scroll through here until we find the snake that we're looking for. There was a couple of snakes. Yeah, that's the one I want. And so I'm going to drag that up into the scene just so we can have a reference to it. And we're going to want to create a material for that. So if we go into our materials folder, and you know, I never renamed our TransportDisc material, so let me go ahead and do that real quick. Rename TransportDisc material. Okay, let's create a new material. And we're just going to use sort of a purple color. Kind of a dark purple, maybe. I think that looks pretty good. And we will call this Coily color. And we can just drag that right onto the model. And now we've got a nice colored, textured Coily for when he's actually in snake form. Now we want to create an empty game object called Coily, and then we want to child that to him, and I'm going to turn that off, and we're going to create a new sphere. So if you've ever played the original Q Bert, Coily starts off basically as a little squishy ball that hops down the pyramid until he reaches the bottom. When he reaches the bottom, he transforms into the snake and chases after Q Bert. So I'm going to call this egg, for lack of a better word. Basically, he's going to hatch into the snake. I'm going to get rid of this sphere collider, and I'm going to move him up to 0.5 on the y-axis. And we're going to use the same material for the egg. And because it looked like Coily was really small compared to the egg, we're going to go ahead and scale him up. And I think that looks pretty good. I think I can live with that. And we're going to want to create some animations for the egg when it squishes and jumps and lands, and we'll use the same animation for both the egg and Coily. Going back to the base here, we will add an animator. And while we're in here, I'm going to go ahead and add a box collider. And we want this to be kind of small, because we only want him to really collide with with Q Bert when he's on the exact same platform as him, or if they're really like passing through each other in the air. So let's edit this collider. I'm going to bring, edit that collider. I'm going to grab this point and bring it up. I'm going to bring that in some. Okay, let me switch to the snake. I think that'll work. So, animations. Let's go ahead and create a prefab for Coily first. So under prefabs, I'm going to create a folder, and I'm going to call it enemies. And we're going to drag Coily into there. And then for scripts, let's create a folder here called enemies. Oop, that's not what we want. We wanted a folder. Let me delete that. I'm going to create folder enemies. Create C# script Coily. I just want to drag that script on the Coily and then apply that to the prefab. Cool. We'll go back into our Coily folder, collapse that, and I'm going to create an animation controller. Animator controller. I will call this Coily Animator Controller. And if we select Coily and under here in his animator, we will drag that controller onto there. So we're going to want to create some animations for Coily. We're going to want to have an idle animation. We want to have a jump animation, and we want to have a land animation, just like we do for Q Bert. So let's rearrange our screen here just a little bit. So playing around with our windows here, just to get a little bit of room for our animator window. I'll right click, I'll say add tab, animation. And we're going to make sure we have Coily selected. And we are going to create a new animation clip. We were going to call this Coily Idle. And you can see it creates the animation in our Coily folder, and we have a new state in our animator controller here for idle. And it will be the default state from entry. Let's work on our animation. We're going to want to add a couple of properties here from Coily. Basically, what we're going to want from Coily are the base, scale, and we're also going to want the egg scale. And so it's automatically created a keyframe here with their default values. And we're going to go out to about 20 frames, and we are going to change the scale. I want to make kind of a breathing animation, if you will. And so we go out to about 20, and I'm going to increase this to say 1.1 on the X and Z. So he's going to kind of squish out. And for the snake, I want him to kind of squish up. All right, and then at around frame 40, let me go ahead and drag this down to about 40. We're going to have him go back to 1 again. And so if we were to click play and look at them in the game view, you can see they're animating. Let's double click on the animation here and look at it in the properties. We want to check loop pose as well as loop time. And I think we're done with the idle animation. So let's duplicate this. And we will call this Coily jump. We do not want this one to loop. And let's work on the egg first. We're going to add another property here. And we want it to be egg position. So we have egg position and we have egg scale. And so this is good for start. We only want to go out about 5 frames here. And I'm going to change this to 0.38. And for his scale, I want to squish him down a little bit. So before he jumps, he's going to kind of squish, if that makes sense. And then at about 10 frames, adjust his position down to 0.27. Actually, I want that to be 0.25. And that should be 1.25, not 125. All right. And then at the 20 frame point, we'll move them up to 0.84. Make this 0.9, 1.7, 0.9. So now he's kind of stretching as he jumps. And then at the 30 frame point, make this 0.84, 0.7, 1.75, 0.7. So there's his jump. And we want to do the same thing for the egg. So let's work on the, not the egg, we want to do the same thing for the snake. So let's work on the snake's stuff here. So at 0, base is fine. On the 5th frame, let's make this, squish him down just a little bit. On the 10th frame, he'll squish horizontally, but begin to stretch vertically. You know what? I think I want to do that on the 10th frame. So let me put this back to 3, 2.09, 3. Go to frame 10, 2.47, 3.63, 2.56. Then in frame 20, 2.4752, 5.41. These are all values that I figured out manually when I was just playing. I wasn't going to make you watch me do this. So now I'm just manually entering them. And then finally, at the end of the animation, so let's go ahead and hit play. And there is his jump animation. We're going to want to add a new state up here. And we'll call this jumping or jump. And we're actually going to want to add a parameter up here. So in our animator, under parameters, click the plus sign. We're going to add a Boolean. And we're going to call that jumping. And so we're going to make a transition from idle to jump. So right click here, make transition. We'll drag it over to jump. Now if you highlight the transition, we don't want to have any exit time. Our condition will be jumping is true. All right, now we want to add another animation for landing. So let's just duplicate this. And we'll call this Coily Land. And let's go take a look at what we want to do in Coily Land. So let's open these up. We're going to want to add our egg position again. So let's pick Coily, click Add Property, Egg, Transform. Oh, we already got it. Okay. Don't know why I didn't see that before. Okay, so this we want to make when he first hits this, he's going to be at 0.75 on the Y. He's going to be a scale of 0.9, 1.25, 0.9. And then the snake will be 2.4752, 5.41, 2.5698. That's when he first gets into the landing. Now we want to drag this down to 0.02 because we want this to happen very quickly. And we're going to move this to 0.25 on the Y. This would be 1.25, 0.5, 1.25, 3.25, 1.5, 3.25. And then out at the 5-second mark, or 5-frame mark, we'll make this 0.5, 1 on all axis for the scale of the egg, and 3 on all axis. So this is basically back to the default position. We're going to delete all of these. And so our landing animation is going to be very short, which we don't want it looping, but anyway, there's that. And so we're going to add a new state up here. So right click, create state, select that and call it land. We will make a transition from jump to land, but we're going to need a new property here. This is going to be a trigger, and we're going to call that landed. So we make a transition, drag it to land, click on that. We once again do not want any exit time. The condition will be landed. Okay. So let me just take a look at these animations. We don't want loop or loop pose. Okay, and we want a transition to go from land back to idle. And that will have an exit time. So let's make that 0.5. I think that's really all we need there. So I think we're good in terms of animations. We're going to want to add some scripting now for Coily to get him jumping. So coming back into our scripts enemies folder, let's double click Coily and expand this here. Get rid of this boilerplate as per usual. We are going to add the tweening, the do tween library. So using dg.tweening. We're going to have some events, and I think that's probably good for now. Let's start adding our serialized fields. We're going to want one for our animator, and we want to have references to both the egg and the snake so we can turn them on and off. And then we want to have a jump delay, which I will default to 0.5 seconds. Let's start adding our private fields. Delay. We'll have a bool for jumping. We'll have a bool for are we dead. We want our transform. And I want to cache the keys for our animator states like we did for Q Bert. So we will have a static read-only integer jumping. That will be animator string to hash jumping. And I want to make sure they're spelled correctly this time so I don't make the mistake like I did for Q Bert. And make this capital L. That one doesn't matter, but this one is crucial that they have the right capitalization. We're going to have a list of vector 3s. for legal jump locations. We don't want him jumping anywhere he's not allowed to, unless he's jumping off the edge because of the transport disk being active. Let's go ahead and import that missing reference. So that added system collections generic. And we're going to want to create our public event here. And we'll call this Coily died. And that should be unity event, not unit event. All right, in the awake method, we will cache our transform. We will instantiate that Coily died event. And we will instantiate our list of legal jump locations. And that's all we need for awake. And on enable, we want to add a listener for the GameManager's game state changed event. So we'll say GameManager.instance.gameStateChanged, add listener on game state changed. And I'll go ahead and create that function here, void on game state changed. All right. Now, what do we do when we create a listener? We want to remove that listener. Okay, so on enable, let's set our jump delay. Let's set the egg active and the snake inactive. So we'll say egg.setActive true, snake.setActive false. So initially, the egg will be active, but the snake will not. Let's add our on game state changed. So we're going to check the game state. So I'm using a pattern. This is a syntax that is fairly new in C#. If you get errors doing this, I'll show you how you can rewrite this. But right now I'm just going to say it's not level complete or Q Bert died. Return. So here's how you can write this if you don't have this syntax. You can say if not, and then in parentheses here, you can say if not, GameManager, if I can type, GameManager.instance.gameState equals level completed, or GameManager.instance.gameState equals Q Bert died. So basically this is saying if it's either level complete or Q Bert died, just return. If it's not one of those, just return. Okay, so what we're checking for, we want to check and see if we either completed a level or if Q Bert died. So that's the non-C#8 way of doing it. If you have C#8, we can use this pattern where you have this is not, this or that. It's just shorter syntax. So the reason we're checking to see if we finished the level or Q Bert died is because if either of those things happen, we want to kill all our tweening. So we don't want, if we have any motion going on with the snake or the egg, we don't want them to keep animating. We want to kill those. And we want to deactivate Coily. So that should take care of what happens if Q Bert dies or if we finish the level. We don't want the snake or the egg to keep hopping around if either of those two things happen. Long-winded explanation for a very simple thing. Okay. let's add a jump method. So this is where we're going to make Coily jump. First of all, we want to set jumping to true. We want to start the jumping animation. So we'll take our animator, set bool. Remember we added that property called jumping. We want to set that to true. And we want to get a random jump location. So we're going to have to add a new function called getRandomJumpLocation. And that's going to be a somewhat complicated function. And basically for now, I'm just going to set it to our current position and return that. Oops. Man, autocomplete. All right, so we'll flesh that function out later. Let's just finish the rest of the logic here for jump. So we're going to want to check and see if this position is out of bounds. Right now we have a function in the BoardManager to check to see if we're landing out of bounds, but we can't access it currently. So if we go into the BoardManager and we look for that landing out of bounds, this function can be made static. In fact, I bet you Ryder, yeah, because we're not referencing any member variables in here. So there's no reason this can't be static. And so now by making this static, we don't have to go through the instance to get to this. So in Coily, if we want to check to see if we're jumping out of bounds, then we can just say if BoardManager dot landing out of bounds location. We don't need to grab the instance. If we are jumping out of bounds and we want to set dead to true, and we want to go to the score manager and we want to score points for killing Coily. And I think 500 points is good for killing Coily. So now we want to actually calculate where we want to jump to off the edge so we can have a real pretty jump to death animation. So we're going to say location equals location off edge. So let me just create another vector 3. Location off edge, vector 3, location. And for now, let's just return location. We will flesh this function out when we get done in here. So from there, we want to do our jump. So we're using the doTween extension method, doJump. We're going to jump to location with a jump power of 25, one time over a duration of 1 second. We're going to set our easing to be a in sign. So we basically want to go into it and then keep going. We don't want to slow down while we're jumping. And we're going to set auto kill to be true. So the tween will be destroyed when it's done. We're going to want to invoke our Coily died event and return. If we're not jumping off the edge, then we just want to do our jump to location. This time, since we're just jumping to another platform, we'll use a jump power of 4, one time over a duration of half a second. We will set our ease to be linear, and we will set auto kill to be true. Okay, now we want to actually code our location off edge, and this is just going to be a little bit of math. So we're going to create a variable here. We'll call it off edge location. We'll initialize it to location. That's what we will return. And we're going to subtract 10 from the y because we know we're going to be going down. So basically, we need to look at our z position. If it is greater than 20, so we're jumping off the right side, we want to add another 10 to that. Else, if it's less than 0, so we're jumping off the left in the z direction, then we want to subtract 10 from it. And we'll also say if that's not the case, if our x is less than 0, then we want to set the off edge location dot x to be negative 10. And I'm actually going to make this an assignment too. Else, if location.x is greater than 18, then off edge location.x will equal 28. Otherwise, we're going to look at our rotation. If we're facing southeast, then we're going to add 10 to our x. Otherwise, we're going to subtract 10 from our z. All right, just a bunch of math. And it would make sense if you understand the pyramid structure. Now, the most complicated function in this file, get random jump location. So we got our position. We're initializing at the transform.position. We want to get our facing, which we'll initialize to transform.yourangles. So if we're an egg, if we're not the snake, if we are the egg, we always want to jump down. We're not chasing Q Bert at this point. We're just jumping down. So if the egg is what's active, then we're going to calculate our legal jump locations. We're going to let the BoardManager do that for us. And then we're going to pick a random one from that list of legal locations. So first of all, GameManager.instance.BoardManager.legal jump locations. We're going to pass it our array of legal jump locations to populate, just so it doesn't have to allocate anything and put any garbage on the stack. And then we are going to return legal jump locations. So that's an array. We're going to get an index into it using random.range 0 location. So that function that we're calling there returns the number of legal locations. And we're going to return an index into it. Down here, we're going to add the code to have Coily figure out how to chase Q Bert. Let's create this function in the BoardManager. So legal jump locations. I'm actually going to add an optional parameter here. So legal jump positions, we need to clear that array. Before we do anything. And now, if we are jumping down, which by default is true, so the egg is always jumping down, so that's why I didn't supply the parameter in this call, because it defaults to true, so we don't need to supply it. So the egg is jumping down. If we're going down, then we're going to loop through all of our down directions. So you remember early on when we were writing this BoardManager, we have an array of all the down directions and up directions. Of course, there's only 2 of each. So we're going to loop through those. We're going to get the landing position, which would be the position that was passed in. I don't know why autocorrect doesn't. There we go. Position plus vector. So we're looping through the vectors going down, and one at a time we're going to take our starting position and add that vector to it. And then we're going to check and see if that's out of bounds. If not, landing out of bounds, landing position, then we're going to add that to our collection of legal jump locations. Okay. And we're going to return legal jump locations.count. Okay, so if we're not jumping down, then we're going to loop through each of the up directions. So vector 3, landing position equals position plus vector. If not, landing out of bounds, landing position, legal jump positions, legal jump locations dot add landing position, return legal jump locations dot count. All right, that should take care of that. Going back into Coily, we still need to handle collisions. So let's look at on collision enter. I'm going to rename this to other. Oops. Other. If we're jumping, we want to set jumping to false. We want to we want to turn off the jumping animation. And we want to trigger our landed animation. And we want to set our jumping delay. Now, whether we're jumping or not, we want to look at what we collided with. We want to see if we collided with Q Bert. And if we did, we want to set dead to be true. We want to kill Q Bert. So we're going to need to add a method to Q Bert to kill him. We want to fire our own Coily died event. And we just want to return at this point. Otherwise, look at our transform position dot y. If it's less than 4, or, I actually want to put this in parentheses here, or the egg is not active, return. So what we're doing here, we've collided with a platform at this point, and we are on the bottom row, and the egg is active. So if we're not on the bottom row or the egg is active, we just return. But if we're on the bottom row and the egg is active, then what we're going to want to do is deactivate the egg. I want to set active. And we want to activate the snake. Let's create this function in Q Bert. So we want to check to see if we're already dead. We don't want to kill Q Bert more than once. And if we're not, then we will set dead to true. We want to stop the music. We want to play our death sound. We want to stop our animator from playing. And we're going to add a speech bubble to Q Bert that has those cartoon swear characters to basically, it's Q Bert's way of saying, darn it. And we're going to fire off, or we're going to notify the GameManager that Q Bert died. So let's, we do already have a speech bubble there, so we can go ahead and say speech bubble dot set active true. And liking that, just want to make sure that speech bubble is not active here. Okay, let's jump out into the Unity editor and set some things up. So let's go look at Coily. We need to add our animator. We need to add our egg. And we need to add our snake. And I'm just going to go ahead and apply all that stuff to the prefab. And let's go look at Q Bert real quick. We need the speech bubble. So we already have a sprite for it, which is that little image right there. But we're going to need to be able to do a little bit of work on that to get that looking the way we want. So if we go in here, we want to change this from default to sprite 2D and UI. Alpha is transparent is good. We want that. We can go ahead and set this to 512. Apply. And there now is a transparent image, and that looks good. So let's go ahead and create on Q Bert a UI image that we will call, actually we're going to rename this canvas that it created speech bubble. And we'll leave that called image, that's fine. This canvas we want to switch to world space. And I think, let me reset these guys. And we're really going to scale this guy down on the X and Y axis. that should all be good for the canvas. Now for the image, we're going to drag in this square image. We are going to set this to be 512 by 512. We're going to rotate it 180 degrees on the y-axis. And I think all that is good. We select Q Bert in the hierarchy. We need to drag in our speech bubble into here. And now Q Bert should be good to go. And we were doing all that on the prefab, so we're good. I should be able to delete this from the scene. I want to go ahead and drag that down now so we have a better view of our game view. And I guess we can give this a quick test just to see if we're able to see the speech bubble. But oh, before I do that, I do want to add a script to that speech bubble. I want to have a script to have it face the camera. We want to make sure that the cartoon text is always facing the camera when it's displayed. So we'll go into Scripts, UI, right-click, Create, C# script. We will call that Face Camera. And double-click that to open it up in the scene, in the editor. So we're going to get rid of this boilerplate. Don't need that. We're going to have a couple of private variables here. We're going to have our camera, and we're going to have our transform. We'll go ahead and cache those in awake. And we're just going to have one simple method, late update. All it's going to do is say transform look at main camera transform. So whatever component this script lives on will always rotate to face the camera. So we'll go back into Unity. We will select Q Bert from our prefabs. We'll select the speech bubble, and we will drag that face camera script onto it. All right, let's go ahead and hit play. And I'm going to move Q Bert down a little bit and pause the game. And we'll go back into our hierarchy under Managers, GameManager. We'll find Q Bert. And we will enable the speech bubble. And then unpause it. And there it is. So we are going to show that speech bubble when Q Bert is killed. Let's go ahead and create an EnemyManager script under Managers. Create C# script, EnemyManager, and we'll double click to open that up in the editor. Zoom in. Get rid of all this boilerplate. I think we're actually going to need that systems collections generic. So we'll leave that for now. Get rid of all this. And we're just going to have a couple of serialized fields for this. We're going to need a prefab for Coily. And we're going to want a spawn delay. And we'll initialize that to 3 seconds. We're going to want to have a list of enemies. We're going to want to have a reference to Coily because there will only ever be one Coily in the game at a time. And a local variable for our, or a member variable for our delay. Let's have a Boolean that we're going to use to see whether or not we should spawn a monster. It's a getter. And basically, we're just going to look at our delay. We're going to say delay minus equals time.delta time, and we're just going to return delay is less than or equal to 0. And that will be what we will use to determine if it's time to spawn a monster. We're also going to check to see if we should spawn a Coily specifically. Oops. So if we're playing and there isn't a Coily already, that will be true. Okay. In Awake, we're going to instantiate our list of enemies. And that's all. In onEnable, we're going to subscribe to the game state changed event. And then in onDisable, we'll remove that listener. And let's implement onGate state change. We'll use a switch statement. We'll say GameManager dot instance game state. The first case will be round started. And then we're also going to care about Q Bert died, level complete, and game over. So if round started, we want to reset our delay. And if Q Bert died or we finished the level or the game ended, we want to destroy all enemies. Okay, so what and destroy all enemies. We'll say if there's a Coily, we'll destroy Coily. And then we're going to destroy every other enemy. And then we'll clear that collection of enemies. We'll implement this Coily, destroy Coily later after we've actually spawned a Coily. So we want to add a method here to spawn a monster. Or I'm going to call it spawn enemy. If we should spawn Coily, then we will instantiate the Coily prefab and parent it to us. And we'll say get component Coily. And we'll add a listener for the Coily died event. And we're going to set our spawn delay. Let's implement on Coily died. From here, we'll call destroy Coily. Now, in destroy Coily, if there isn't a Coily, just return. This should never happen, but I just want to be safe. We're going to remove our listener from Coily died. And we are going to destroy the game object for Coily. And set Coily to null. That should take care of that. Now, we need to add an update method. And in here, we'll just say, if not, should spawn monster return. Otherwise, spawn enemy. So I want to rename this to should spawn enemy. There we go. That should take care of spawning Coily. And Ryder is yelling at us because we never use this enemies collection, but this will be utilized when we add enemies besides Coily, like Wrong Way and I forget their names, Rough or something. Anyway, we will have other enemies and we'll make use of this. In the meantime, we need to go back into the Unity editor. We want to go to our resources, managers, pick our GameManager, and we want to add that EnemyManager script to it. So we need to add our Coily prefab. And that should take care of that. So let's give this a test and see what happens. Nothing. Well, we haven't told it where to spawn the monsters at yet. And Coily always spawns in the same place. So what we really need to do is go into Coily and we need to set something in his prefab to say where he's going to spawn. And he's always going to spawn in the, not the very top platform, but the one down and to the left of it. So that would be 18, 15. So if we hit play, well, he's there and he's idling extremely fast, but he's not jumping. But he did spawn in the right place, so that was good. So there's a lot of things wrong there. I'm not really sure what to diagnose first. I guess I could look at the animation. One thing I noticed is I forgot to add a rigid body to Coily. So let me go ahead and add component, rigid body. And I know I'm going to want to freeze his rotation. And we're just going to manually control his rotation. His gravity and everything should be fine. Okay, so the animation was running too fast. So if we double click him and we open up his animator, select him here and hit play on idle. Okay, for some reason these are totally wrong in terms of the time. I'm sure I wanted these to be at 20 frames and 40 frames. So let's just grab all these and drag them over to there. And then I'm going to drag all these over to there. And I'm going to hit save. Now I wonder if that messed up the other animations. Hopefully not. It looks like it may have. It's like they're linked somehow, which is not what I wanted at all. So the problem was I tried to be too cute and lazy, and I just duplicated this idle animation. That's not what I wanted to do, apparently. So I'm going to rename this. And I'm going to rename this. I'm only keeping them around temporarily so I can get the values off of them. Actually, there's no point. So I just delete them. I need to pick Coily, come over here and say create new clip. Call this Coily jump. And add property. We're going to want the eggs position and scale. Okay. So looking at that, 0, 0.5, 1, 1, 1. We're also going to want the snake's scale. Sorry to make you all watch me do this again. All right, and that's 3, 3, 3. That's fine. We want to go up to the 5th frame, and we're going to want to add a new keyframe, and that's going to be 0.38, 1.125, 0.75, 1.125, 2.09. We're going to go up to the 10th frame, add a new keyframe, and that would be 0.27, 1.25, 0.5, 1.25, 2.47, 3.63, 2.56. Then we will go over to the 20th frame, add a new keyframe, 0.84, 0.9, 1.7, 0.9, 2.4752, 5.41, 2.5698. And the last one, which will be frame 30, add new keyframe, and that'll be 0.84, 0.7, 1.75, 0.7, 2.4752, 5.41, 2.5698. And then we will delete these. And we are done with jump. Select Coily up here, create new clip, Coily land. And I'm just going to fast forward through this for your benefit. And we'll copy that up to there. Okay. And then we will copy that up to there. And idle should already be fine. All right, let's hit play and see what happens. Oh, he fell. Why would he fall? He's got a rigid body. He's got, doesn't he have a collider? He's got a collider. Could it be a layer problem? Let's go into the project settings, physics. I think we need platform to collide with default. We probably should add an enemy layer to handle Coily, but let's see if this fixes the problem. There he is, and he is idling, but he's not jumping. So the next issue to debug is, why isn't Coily jumping? So this is a good opportunity to look at some debugging techniques. Let's go into the Coily script. So we have set active true. We need to look at our update method. Where is the update method? Did we never write an update method? Well, I think we just found our problem. Sometimes I just get going so fast and I miss little details. So I think right after onDisable, we'll add update. If we're jumping or we're dead, we'll just return. Otherwise, we want to subtract time.delta time from our delay. I could add a property called should jump where I do this, which is what I usually do. But I'll just go ahead and I'll call if delay is less than or equal to 0, jump. And I'm actually going to do this. I'm going to add a property. So we'll say bool can jump. We'll have a getter. And we will say delay. Actually, I'm just going to copy this code. And I'll just return that. And then down here, if can jump, jump. I just like to make my code readable so it's obvious here what I'm doing. If I can jump, I'm going to jump. All right, let's go back into the Unity editor. Hit play and see if Coily doesn't jump. Oh, I actually want to maximize my game view here. Well, that's not right. We never implemented that piece. I think it's interesting that he only jumped the one direction. He should be getting two possible legal directions to jump and then randomly choosing between them. It looked like he always went down and to the right. No, there he goes. It was just luck of the draw. Alright, so now we need to implement getting him to chase the player. So let's open up the Coily script and go see what we forgot to implement. Down here, we didn't implement the code to get Coily to chase Q Bert. This is going to be a little bit more complicated, which is why I put it off. Let's see. Let's get our Y offset first. So basically, if Q Bert is above us, we want to go up. If he's below us, we want to go down. Okay. And we're going to add that to our position. Now let's do a switch on this, because where we go horizontally will depend on where we're going vertically. And I'm going to document this with some comments. So Q Bert is below and to the left of Snake. So and again, this syntax is kind of new to newer versions of C#. So you might have to write this a little bit differently if you're using an older version of Unity. All right, so if Q Bert is below and to the left of the snake, then we're going to go -3 on the Z direction and turn to face southwest. If he's below and to the right, so case less than 0, he's below, then all we need to do is add 3 to our X and rotate our facing to be southeast. Let's see, Q Bert is above and to the right of Snake, so it's greater than 0. We're going to use the when clause. So basically what I'm putting in a when, here you would put in an if statement inside the case for cases greater than 0, and you'd split this up, and it'd be just one case statement for cases less than 0 and one case statement for greater than 0. And then instead of doing this when and having a separate case, you would just have an if else. So, if Q Bert's above and to the right, then we add 3 to Z and turn to face northeast. Otherwise, if he's above, then he has to be above and to the left. So all we say is position.x minus equals 3. Change our facing to be northwest. Otherwise, if we're on the same level, then we're going to call that legal jump locations function on the BoardManager just to figure out where he should jump. So we'll say int legal locations equals GameManager.instance.BoardManager.legal jump locations. Legal jump locations. Transform.position. Y is greater than 6. It's yelling at me and saying this is inefficient because we're referencing transform position more than once. And it wants me to introduce a variable. But I honestly don't care. So that gets me my legal positions. Now our position will be a random one of those. Okay, that's it for the switch statement. Now outside the switch, we'll go ahead and do a do rotate to facing over 1/4 of a second. And we'll set our easing to be linear. And we'll set auto kill. And we'll turn position. All right. Heuristically unreachable. Is it? I don't think it is, because it could, instead of being less than 0, it could be 0. That's interesting. Well, let's go back into Unity and see if Coily will chase the player. We got some stuff to handle when he jumps off, but he definitely was chasing the player, no doubt about that. So we'll jump back into the scripts, and I actually want to look at the EnemyManager, and I want to go down to where we get the on Coily died event. I think this is the problem. So this is getting fired by the Coily script when Coily jumps off the edge. I'm firing that before he can even complete this jump animation. So I think what I want to do in here is say invoke name of destroy Coily, and I'll give him 2 seconds. I think that looks good. Let's go give that another test. Now, I also want to see if we got the 500 points for when Coily jumped off the edge. Yes, we got the 500 points and Coily went off the edge. Very nice. Let's see if it goes over the other side. Oops. I needed to wait for him to get closer to me. Oops. Well, we know that works. Let me try that again. See if I can get him to jump off the left side. I'm going to add some special logic for that. He does it on this side without any special logic, but it looks like I'm going to need to add some special logic to have him jump off when I'm on the other side. But this video is getting long enough, so I think I'm going to call that a wrap. We got our transport disc added, which was good progress. We got Coily the Snake added. We got him animated and chasing after the player and killing the player and jumping off the edge on one side at least. So I think I'm going to say that that's all we're going to do in this video, and I really do appreciate you all tuning in and watching. If you found this video useful, do me a favor and click that like and subscribe button. It really does help me to grow my channel. If you have any questions or comments about anything that you saw in this video or anything you'd like to see, drop a comment below, and I promise you I'll read them and get back to you as soon as I can. So thanks so much for watching, and good luck on your game development journey.